let's start. So it's really a great pleasure to have this first keynote talk at ECIR this year. Ricardo Baeza-Yates is a leading scientist in our field. We all know him. Possibly he doesn't need any introduction, but he's a research professor at the Institute for Experiential AI of the Northeastern University in the US, and he is also part-time professor at the Universitat Pompeu Fabra in Barcelona and Universidad de Chile in Santiago. We all know Ricardo not only for his academic merits, but also because of his industrial career. He was vice president of research at the Yahoo Labs in Barcelona and then at Sunnyvale in California. He wrote one of the seminal books in information retrieval, textbooks, Modern Information Retrieval, and he has won many awards in his long career, among which is an ACM Fellow and an IEEE Fellow. So, as I was saying, it's a pleasure and it's an honor to have Ricardo talking to us about ethics in AI this afternoon. And I must say, I have a little bit of emotion because Ricardo was one of the members of my Ph.D. Viva committee, so it's really a big thing to be chairing his session. So, Ricardo.
Thank you, Nicola, and thank you for the introduction. I still remember your PhD defense, nice defense in Padua, right? So we'll share my presentation, and it's not a presentation on search or information retrieval. It's something I have been working lately. I would say the last past year. Many people know that I have been working on bias for more than 10 years, bias in search. But now I move a little bit also to ethics in AI, which is the next step if you want to solve bias. And I will stop my video just to have a better internet for the presentation. So 1 second. And bear with me that this is, I guess, one of the first time I give this talk. So still is being, I guess, evolved, and it will always be changing in the future, I guess. So before I start the presentation, I would like to tell you a little bit, one slide about where I'm working now. So I'm half-time in the Institute for Experiential AI. It's a new institute that started last December in Northeastern University. That headquarters will be still working out in Portland, Maine, but we will have people in Boston, which is the main campus of Northeastern, and also in many other places, including where I am, which is in the Silicon Valley, where there's another campus of the university. There are like 3 in the West Coast, 3 in the East Coast, and also 1 in London. And the idea is that when you see real successful operations of applied AI, you see 2 main things. One is humans in the loop, or as I like to say, humans in control. So basically, humans are involved in decision-making from the design to the operation. And you see the strong dependence on data, where sadly, instead of having new algorithms today, we just put more data. But basically, these 2 things are what you see are reasons to have a good AI application. And one of the areas that we'll push here is responsible AI. So that's why this talk. But also another area, and we're working on that, is something we call information retrieval 3.0. So maybe in the future I can talk to you about that, what it means information retrieval 3.0. Of course, 2.0 will be web search. Everything what happened in the last, let's say, 30 years, well, 20 years, and before was traditional AI, IR. So the agenda has two parts. The first part will be a series of examples, not all of them are well known, and of course have my selection bias, so it's not perfect. And this is the list. I will get back to that later. And the second one is 4 genetic issues that I think are important, that is still in the making. I think it's very early on the field. There are, for example, very few ethicists that really understand AI, and most computer science people don't understand AI completely well. So these are the 4 topics, and here I have to thank Lorena Jaume Palazzi, which is my in some sense my ethics teacher. And we will finish with some last remarks. So the first problem will be bias. So bias is one of the main problems in being able to have ethics in AI, and it's basically what we do with bias in data. Well, all data has some bias. I mean, it should, because it has some information, and we cannot use data that doesn't have any information. So the first thing to say here is that we have the bias to think about bias in a negative way, because we only see in the news the word bias when something wrong happens. Of course, bias is neutral, can be positive or negative, but now our mind associates bias with something negative. So let's try to be aware of that. It doesn't have a sentiment in principle. Well, then we need to ask if the algorithm should be neutral, should be fair. But most of the time we not even ask these questions and just have the same bias in the output. But bad news, sometimes the bias is amplified. And then if we amplify the bias, we cannot blame only the data. We have to blame something else. Even sometimes we have new biases. So biases that we didn't expect. So it's very important to remember that bias is not only in the data, and here you can also check my bias on the web paper in 2018, or see my ACM Brexit keynote last year on bias in search and recommender systems, which is available in YouTube. Sometimes the algorithms create new biases. Sadly, I will not be able to cover this in the talk, but not only the algorithm can create bias, but also the feedback loop between the algorithm and the user creates additional bias. And I will touch a little bit that because I think that's one of the open problems, not only in search and recommender systems, in basically in interactive systems today. Well, what is being fair? So this is if we ask the question, we need to understand the answer. And being fair could be equality, equity, or justice. Usually we do equity. Basically, we do some affirmative action to help the people that basically doesn't get the same treatment. But of course, justice will be to remove the problem, and that takes longer. So that is left to society, and there are many things that have been solved, but still we are working on this. Now, if you're interested in this topic, I will recommend this movie. In the US, will be soon available in PBS, but in other parts you can organize a presentation. So it's not expensive, so you can organize a group and see a presentation of the movie online. And by chance, when I was invited a few days ago to give this keynote, I already accepted to be in a panel that is later today, so will be at 8:30 p.m. in Europe of a panel on the topic of this movie, which is basically bias in systems. So if you are interested, please come. Will be there Dame Wendy Hall, Natalia Sweeney, a federal judge, and all moderated by Gina Matthews. So what is the answer to this question? Well, the answer is that not always you need to worry about this question. For example, in many AI applications, there is no, for example, social bias, which is the most important. But if you harm people, or you have the potential to indirectly harm people, you need to worry about this question. So you need to ask yourself what is to be fair, and that means you need to apply an ethical view of the whole problem. Now, how you solve this problem? There are many solutions. So one, you can debias the input, which is maybe the best if the bias comes only from data. If you're lucky, only data. But many times we don't know what is the bias. So, and we don't know what is the right reference value. For example, what should be the right percentage of women in this talk? Maybe it's 50%, but society doesn't agree sometimes in some of these values. The second one is tuning the algorithm. So making, say, the ML technique, and in search we have a very good example of that. So we have from the work of Thorsten Jokins initially, to do learning to rank where bias is addressed from the start. And finally, the easiest solution is to debias the output. So we try to fix the output. For example, I have some work here on re-ranking the output. Let's say you're searching people and you want to put more women on the top. However, not always you can solve the problem well, because if the output doesn't have, for example, enough women, we only can change the order of the ranking, but we cannot put like 50% women in the answer. So it's the easiest, but it's not enough many times. So a bit more than 4 years ago, the ACM US Technology Policy Committee and Council basically did a statement on the 7 properties that algorithms should fulfill to have transparency and accountability. And I'm part of this, of one of the committees today of AI and algorithms. So I will not read the list, but the first one is maybe the one that we have to do at the beginning, awareness. If we are not aware of the problem, we can never solve it. So for example, I'm not aware of many things I say that may be biased because I don't realize them. I just culturally accustomed to say them, and I need to train myself, and have done it, to don't say those things. But if someone doesn't tell you that that's an issue, and then you also listen and believe it, that will never be solved. So very important here to remind that systems do not need to be perfect. Sometimes we ask for systems that they need to be better than, that they need to be perfect, but just they need to be better than us. So surely self-driving cars will kill people, but will kill many, many less people than people do today, because they don't get tired, they don't need to look at the cell phone, of course they don't sleep, they don't drink alcohol, and so on. There are so many reasons that will be better than us. So let's start with the examples. So the first set of examples is on discrimination. So the first one that you see is gender and race. And this is one of the first classical examples, was the Amazon hiring problem, where was discriminated women. But then we had facial recognition, which is the main topic that the movie Coded Bias starts. And basically in 2019, it was clear that many, many systems had racial bias, not only in the case of the lab with women, but also with race. And there was a very interesting paper that appeared a bit more than 2 months, maybe more than 1 month ago, that shows that the collections of faces that we have been using to improve this technology, this facial recognition technology, has grown exponentially. So you see that the x-axis here has a logarithmic scale. Sorry, the y-axis has a logarithmic scale. And then you see that things have been grown. But how this thing has been grown? Well, this started with a very curated collection done by people. So at the beginning, in the first period, 100% of the collections were done by people. So that period was until 96. And then when we arrived to the third period that started in 2007, and especially the last one in 2014, most of the faces came from web search. What that means? That means that there was no consent from that people to basically say, yeah, I'm fine to use my face for research on face recognition. So in some sense, here we have a paradox that all the technology that has been developed here has been developed a bit unethical because there was no consent of the participants of the face databases. And all this ended when basically Amazon, Microsoft, and IBM recognized, although Amazon, for example, didn't at the beginning, IBM immediately recognized that this was a problem and then stopped selling facial recognition to law enforcement. I think also they should stop selling this at all, and some of them have stopped that too. But the same month, so less than a year ago, in June 30, 2020, the USTPC also urged the suspension of using facial recognition technologies, and one of the people signing this. And after this, also cities in the US started to basically prohibit this kind of technology. So the first one was San Francisco, the second was Somerville in Massachusetts, and the third was Oakland in California again. And many other cities have done the same because they realized that these discriminate people. And the problem is that the systems still are out there, that even with this stop of selling the technology, you see problems. This one from September 2020, where the second African American basically sued the police because of a wrong arrest. And if you see the coded bias film, you will see the case of London, where they put for a few weeks as a pilot face recognition in the streets of a poor neighborhood of London, and basically an NGO found that most of the people accused of being a criminal were false matches. So this was, in that case, it's even worse, and luckily this was stopped. And there's a recent paper by Selinger and Herzog that shows that basically giving consent is impossible in facial recognition, and they explain very well why that is the case. And then we have also gender bias in translation. So if you have seen already my talk on bias in search, you have seen this problem. And recently there was many people putting an example in Hungarian in Twitter, and was very popular. So this problem appears one and again and has been going around for several years. So before 2020, if you go to translate here, for example, here I'm using Turkish. This happens in all languages that don't have gender in the pronouns. And I put this back to translate back to English, then you will see that the gender is changed because the most common thing that you learn, the system learns from text, is that she's the babysitter and he's the doctor. Well, if you try this has been solved partially by now today. If you put many sentences, hasn't been solved. So you put 10 sentences in a row, you will see that there's still gender discrimination. But this is interesting that now, if you try these 2 sentences, both are women now. And I don't know why in the second case they use uppercase for she. So at least now she's a doctor, but still she's the babysitter and not he. If you do, by the way, if you do just 1 sentence, you will get that both genders. So with 1 sentence is correct. And this has been shown in many papers. One of the most earlier ones was in NeurIPS 2016 when it was in Barcelona, where they were trying to find she, he analogies. And you see that most of them had a stereotype. So instead of getting something like Queen King, if she's a nurse, he's a surgeon. And if he's a superstar, she's a diva. And we know that there are some negative connotations for diva. So I did some research here. So maybe because this is text coming from news, most journalists in the US are men. I found out that yes, that's the case. Most influential journalists in the US are men. But I found, surprisingly, that at college it's the inverse. Most students are women. So here you have not only a gender bias in writing, but you have also gender bias in a profession, and women journalists that I have met tell me that's true in many, many countries. So then when you have this problem in text, well, this will affect word embeddings. Here's one of the early papers on word embeddings from the work is from 2017, but the paper was published in March 2018 by people in Stanford. And here you see many, many gender and ethnic stereotypes. So housekeeper if you're Hispanic, you're a conductor or a secretary if you're Asian. But for example, if you want to be administrator or a sheriff, probably you're white. And then if you have word embeddings, then you have language models. And these are very important to us for people that work with search. And we have using a lot of language models to improve search in the last years. So the table here on the size of the language model, the number of parameters, here we have from BERT in 2019 to the last one from Google, where you have 1.6 trillion parameters. So this is very similar to the size of the text in words that you are using for training. So how much overfitting we have when we go over 1 trillion parameters? I don't know, but clearly there's some overfitting, because if you try something smaller like GPT-3 that has 175 billion parameters, in a recent paper in January, they showed that there's anti-Muslim bias. So basically, for example, here are some completions of the sentence, 2 Muslims walked into A, and you can see their completions are not nice. Maybe the only last one I can read it. In a bar, are you really surprised when the punchline is they were asked to leave? But the other completions are basically violent. And when you do the analysis, you see that the number of violent completions for Muslims is more than 4 times the same of Christians. And well, seems that the Buddhists and atheists are the less violent, at least in the news. Of course, that's not the case, but this is how people write the news. So be aware of this when you're using language models, because it's not only anti-religion, but also gender and other things. But discrimination can be much more complicated. For example, what about discrimination in ads? And some work here from a team in Northeastern University. Or for example, more complicated things. For example, this company that was accusing TikTok of discriminating in the post. Or lot of Italians in the I guess in the audience, so maybe you know this. In January, the landmark case of discrimination against riders that work for the Deliveroo platform, where the judge ruled that there was indirect bias, indirect discrimination, because people that couldn't deliver food at dinner time were discriminated, and of course later received less work. And here, of course, we cannot blame any data. We have to blame the system that was trying to optimize how to deliver more food to earn more money. And then if you try to deliver more food in the most important time of the day, that is maybe dinner, then of course you will get some kind of indirect bias because of the optimization function that you are trying to improve. Remember, even with the best of intentions, your optimizing function may harm people, so you need to have an ethical look to your optimization function. Not just say, okay, I want to earn more money. You need to say, okay, also let's do, for example, a fair schedule of how we give the work to people. Then we can go to police examples, which are gets worse. So I already showed one case of discrimination using facial recognition, but it's even worse because Palantir, a company, started this system a long time ago, more than 10 years ago, of criminal profiling. So like if you saw Minority Report, the movie, so I will predict if you will commit a crime in the future. And of course, this is a very sensitive topic. And also we will have a lot of people against because it's not ethical. And in Los Angeles was done via the police foundation, so the city hall didn't have to inform. In New York was just bought by the mayor. You can imagine who was the mayor, never approved, was approved by the city council. New Orleans, they approved it, but was secret until someone basically filtered the information to the public. And it seems that some even countries in Europe are using this. If someone in Germany can basically confirm, I found some news that maybe in 2019 this has been used. The problem here is that even if it works, even if you have 90% precision or accuracy, one error and one person is really, really harmed. So I will get back to this because this ethics is not about accuracy. Ethics is about the impact of the errors. And we need to work more on that. Another system, similar system, PredPol, that was done by the IIT and the Chicago City, another criminal profiler. And here I use it separately because there's a nice example of how we get a geographic bias, because basically we are looking at the regions where we see more crime, but of course that doesn't mean that there's no crime in other places. So what we get a self-fulfilled prophecy that we see more crime where we are measuring the crime. But of course, if we measure everywhere in the same way, the distribution will be different, and we will get back to this. This is an example from Spain, which is now not about trying to detect crime in the people doing the crime, but in the victims of the crime. So this system started being used in 2018 by the police to see if basically the police reports on robbery were true or not, if the people was lying to the police. And here is one of the news from 2020, and this is kind of funny when it says when police is not stupid. Well, maybe they're not stupid, but they are not ethical. And this was recognized right away in Germany when a similar EU project was trying to do an AI lie detector, and the pirate party challenged in court right away in February this year. But for example, in Spain, this system has not been challenged in court. I will get back to that because also this is related to GDPR in Europe, and I will get back to that. Injustice may be the most famous case, one of the cases that started to have a public attention was the Compass criminal profiling system. Of course, was created as a support tool, not a decision tool. But we know that basically people has a bias to accept recommendations from tools. There are some work, very early work, even in the 80s, when there was an expert system that was doing something similar. There was found that the judges were prone to choose these recommendations and not challenge them. So here was about race bias. And this is well known, but I had to include it because it's one of the most well-known cases. But here, then I have two important questions. One is a circuit algorithm ethical? So if an algorithm is harming people, should be secret, and this is the case. However, there's another important question that is a public algorithm safe? There are many cases that we know people game the algorithm when they know how the algorithm works. And there are many interesting cases. One that is not similar to this, but very interesting, is when Blair decided in the UK that doctors will get an incentive if they will basically attend people in 48 hours. And after that, the system, instead of improving, got worse. And why it got worse? Because basically the doctor stopped making appointments with more than 48 hours in advance. So when you put an incentive, you stop, you create other biases, and something very important, when you measure a success measure, then maybe that measure is not longer about success. Let me give you an interesting example from justice that explain a little bit what are the problems that you have when you deal with bias. Here is the problem of bails in New York. So we want to predict if we should have to give a bail to an offender. Of course, we don't know if it's real offender or not. It's a potential offender. And then, of course, if the person gets bail and pays, gets out, if gets bail and doesn't have the money, will go to prison. However, in the US, there are some people that lend money to people to pay bails. So basically, not only the judge had to do this prediction, but also these lenders also have to do the same prediction. And if you are poor, or if you don't take the risk of asking the lender, or basically the system say no bail, you will go to prison. However, in New York, they look only at the question if you will appear in court. So the judge cannot think about if the person will reoffend, which is very hard, because if I know I have like a potential killer, you will have to think first on that and not if the person will appear in court or not. What is the problem in this case? The main problem in this case is that we do not know what would have happened if the person had bail. So we have like half of the data. We have which ones appears in court and which ones reoffended, but only for people that got bail. So here we will need to do some data imputation, and it's something that happens also in the policing prediction, and it's very important because how to do the data potential will be crucial to have a fair model. So in this paper by Kleinberg et al., published in 2018, one of my favorite papers on bias, they show that they could decrease the criminal rate in 25%, keeping the same prison rate, or decrease the prison rate in 42% keeping the same crime rate. So why was the case? Well, for example, if the model is right, of course, it is a prediction, but if the model is right, judges were bailing half of the most dangerous criminals that failed to reappear in 56% and reoffend in 62% of the cases. So this is the issue. And this is how they solve it. They use many data sets. So they divide the data set in many subsets. So one to do the training, one to do the data imputation, one to hold out to validate the results, and some in a lockbox where some external person could check that the results were really correct, or at least valid. So for this, they use, because there's not much data, though, they use decision trees, so gradient and Bootstrap decision trees. And also they use 18 features where the only demographic feature was the age. For example, the gender is almost, most of them are male, but still they didn't use that. And of course, all the information about the case, the history of the person and so on. So what was the result? Well, if you see the statistics, the judges are racist. So here on the red, I put the percentage of people in New York of these ethnic descendants. And also here you have the judge. So for example, the judge sees 49% African Americans in the offenders. So it's already, so here is the police bias. So basically people arrested jumped from 18% in population to 49% in the offenders. But then the people that doesn't get bail even increases to 57%. And if you're Hispanic, it's the opposite, but in overall, in these two minorities, you jump from 82 to 89%. What about the algorithm? What about the model? And for me, a model is an algorithm. So some people also, they say that it's not an algorithm. Well, you need to execute the model, and you execute the model with an algorithm. So don't try to hide algorithms in models. So, so sadly, the algorithm got more racist than the judge. So the algorithm amplified the bias. Here you see from 57% to 60% in African Americans. But it still was doing better than the judge. So in some sense, the algorithm was more racist, but also was more fair. And that's an important question, because what was happening, and this is the way that they did the data imputation, they divided the judges in 5 groups. So they used the most lenient judges to predict the most hard judges. And if you basically say, okay, I will put more people in prison, you will see that the algorithm will do this, right? So basically the algorithm will take the top of the group. So it will be these ones here. But if you see, judges choose people from all over the spectrum of risk according to the model. Remember, this is a prediction, so the model might be wrong. But according to the model, basically the judge is basically almost doing a random choice. So here we have a dilemma. So what is better, a biased just algorithm or a noisy judge? And here you see the difference between noise and bias, but I think I would prefer a more fair algorithm, even if it's racist, because at least I get the same treatment than people that have the same issue. And this is very important. It's another topic I will not touch today, but I give the reference to this 2016 Harvard Business Review paper, is the huge cost that society pays from inconsistent decision-making that not only happens in justice, that happens in many other places, particularly companies. Well, let's go to the second set of examples. This will be shorter because discrimination is the main one. But the first one is what is called physiognomy. And basically this started with the Greeks a long time ago, that basically you can predict personality traits looking at your face. And then it was people in Stanford that in 2017 said that using facial recognition tools could predict sexual orientation of a person. And of course, this got a lot of bad publicity. Later in China and last year in the US, some people said that they could predict if you could be a criminal in the future. And of course, this got also, again, a lot of bad press. This was very weird because when in 2019 someone in China did this, the community really complained, the research community, but then again other people tried to do the same in the US. And the last paper by Kosinski, published in one of the Nature journals, again used facial recognition technology, although this has a name, this is biometrics technology, can expose political orientation of facial images. This is not as bad as sexual orientation, but still is not ethical. So also doesn't work. This paper gets a 70% accuracy, but of course these are spurious biases that are maybe related to many other things that maybe we are not aware today. But if you can say that you can look at my face and know what kind of political orientation I will have, I think that's causality that doesn't exist. Here we have two more problems hidden in this paper, is that the IRB of Stanford approved the research, so didn't check if the question was ethical, because even if you can do this, you shouldn't do it. So even if you can predict this, you shouldn't do it. It's not ethical. And then we have a paper from the Nature group that published this paper. So basically, there's no ethics control in publications. So we are having like a big hole for this kind of unethical papers in the system. And this is related to phrenology. Phrenology is very similar to physiognomy, but basically in phrenology, you think that, for example, your bone structure is different, and then there is a physical thing that you can find if you are a criminal. And one of the main exponents of this, and I had to put this because I think some people may be interested, is Dr. Cesare Lombroso in Torino in the 19th century, that really believed this. And you can go to his house museum in Torino, and I did it's like 3 years ago, and you can see hundreds of basically skulls that he collected from poor people, so these people that basically died in the street, who he could take the skull. So there's some kind of a discrimination there. So the only skulls of poor people are here. I'm talking about many skulls. So these are some examples. And he left also his skeleton there as part of the museum, I guess, to have at least one skull that basically cannot be a criminal. So this will be a positive case for him. So, but this can be worse. Pseudoscience can be worse. For example, here is not from Stanford, from MIT. This paper that claims that if you give some voice, then they can draw your picture. I can believe that maybe the part of that where the mouth is may be related to the way you speak. But for example, I'm sure if I test this with an adopted person from, let's say, China and speaks Italian, will not get the right face. So again, the problems are the errors, not the successes. And then with this, I have my master phrenology algorithm. So please send me a piece of voice. I will then generate your face. And with all the other research, I will check if you're a possible criminal, possible political opposer, and also if you're homosexual. And you know, this is a crime in some countries. So this is something that you shouldn't do. So really is something unethical. Let's go to the third set of examples, this unfair e-commerce. And maybe you have seen this because this happens in search and recommended systems, is the famous filter bubble. So basically, I may know Nicola or Raffaele or Fabrizio from a long time, and I can predict what they want. But I will never be able to predict something that they don't know because it's not in the data, and that may like. So we, sorry about that. So we have partial knowledge of the user, and today we are working on this thing. We use diversity, novelty, serendipity, and so on. And there are more and more other examples in, for example, e-commerce platforms. So, and what the problem here is the dangerous feedback loop. So we don't know our world well enough. Basically, we are doing short-term optimization, and then the system itself is in a bubble. So you can think that the system is in a bubble that is the union of all the user bubbles that use that system. And here you have a massive effect, not only for people, but also for providers. So basically, the players of the systems or products of the system are discriminated, and the rich get richer, and the poor get poorer. And then we have to remember that unfair markets are unhealthy, and they're less stable in the long term. So e-commerce platforms should really be worried about this because they are not getting the best from the world. And this is like iceberg effect. So exposure bias is what you can see. So in recommendations, you may see 3-4 recommendations, but there are millions below. So it's even worse than an iceberg, is that you are looking only at the top ice cube of the iceberg. And you need to look also to the rest. The next set of examples are what I call stupid models. And here I remember this famous sentence by George Box that all models are wrong, but some are useful. And he was referring to statistical models. But you know, machine learning models are also at the end statistics. So it's still valid. So these are models that really are not intelligent. I mean, today we have shallow AI. The models don't really understand the semantics of what they are doing. And for example, models cannot deal with irrational behavior. So when Elon Musk say, use Signal, this small company in Texas jumped his stock value in 400% because some AI system that uses Twitter as input thought that he was talking about this company. Models that are too sensitive, like, for example, one pixel attack. This is a paper from Japan. I forgot to put the authors here. Change one pixel, and then the prediction changes completely from a bird to a frog, from a cat to a bird, from a ship to an airplane, you name it. And here we need to remember our limitations. So to abstract, you need to forget. And here I always like to remember this beautiful story by Borges, Funes de Memorius, a person that couldn't forget. So basically couldn't summarize any experience. And then we need to remember that we cannot learn what is not in the data. So how many systems will predict, well, this animal? Because how many people take pictures of this animal from below a glass table? I guess you can, but most systems will not. And again, accuracy is not the main thing, it's the impact of error. For example, usually false negatives are worse than false positives. Let's say illness detection in medicine. And many errors are not human. And this is something that is touched also at the end of the Coded Bias movie. And those errors have a large negative impact. Imagine now that you measure the impact instead of the accuracy. Of course, the solutions will be very different. So be humble. If you're not sure, tell the model to say, I don't know. I know very people that has this kind of category. If your confidence is low, and even if it's less than 80% or 90%, please say, I don't know. It's much better. Then you will not impact any people. And then the last set of examples is this waste of resources. And this is the famous Parrots paper. You have, for example, 57 years of carbon footprint of a normal person, or you are spending $3 million to train a model that has bias. So this paper appeared recently in the FACT conference, and Margaret Mitchell, couldn't use her name because at that time she was employed by Google, and Google didn't allow her to be in the paper. So this is a good time to switch topic. It's kind of meta ethics when a company basically in 2 months fires the 2 people that leads the ethics in AI team. That means something. That means maybe that companies don't know how to handle ethics. Also because the firing was not very ethical too. So some pragmatical questions. And now this is the last part. I will go fast because I see I have taken a bit too much time. And sorry, remember, this is the first time I give this talk as a keynote. So to which part the principle applies? Are all equally important? To whom is important? Are they orthogonal? Can they fulfill simultaneously? Can I do it? Do they make sense together? For example, in Italy, people will ask for transparency, and in the UK, people will ask for accountability. They're two different, but maybe you cannot have both. It doesn't make sense because we ask for different things because we have different cultures. And here is a paper I'm working on, and this is a classification of 30 different things that you can ask to the system. Some of them are more ethical than others, and so I have an ethical level of every principle. But you see that some are applied to the data, some are applied to the algorithm, some apply to the whole system, some apply to the governance of the system, and some are interested to the user or to the government or to the justice or to the whole people. And then you can put things in groups. So these are tentatively my 6 groups of importance. So one is about awareness of the system, so what the system is doing, everything about data provenance, and here bias is important, everything about completeness, and this is more about the system, everything about usability, this is more about the user, everything about transparency, so basically this will be very important in most developing countries, and responsibility is basically thinking how to do this well. Then we have cultural differences. So for example, this is a very interesting map from a research group in Canada that show how also we are doing legal and ethical colonialism, and basically civil law of Europe, common law of the UK, Muslim law of the Arab world is basically the 3 dominant laws in the world today. And and we have to deal with this. And in the case of civil and common law, this is part of what is called technological humanism. And sadly, humanism has some historical biases encoded in the development of this philosophy. So humanism semantically should be something nice, but it's not that nice. And then you have even religious difference. So for example, you have the Christian way to do this, to look at this. So for example, legality and morality, and then moral ethics and law. And they are not one inside the other, but in Muslim law they are. So in the Muslim world, so every law is inside ethics, which is for me is more reasonable, and ethics is inside moral. And this will be much easier for lawyers if they will understand the world like this. And then law increases and covers more of the ethics. And some other people propose other things that are even more weird. So here we have geographical diversity, and here I want to mention Ubuntu for the ones that don't know the origin of the word Ubuntu. I'm not talking about Linux. And Ubuntu comes from Southern Africa, and basically says that I exist because you exist. And there's a very interesting blog posting by Aveva Birhane that basically says that Descartes was wrong because a person is a person through other persons. And I believe this. Alone, I'm not nobody. I am because I have this social network that I care of the people that I love. So also here, the regulation is important. So we have things like identity, data protection, and privacy. In this recent book, second edition by Carissa Bellis, Privacy is Power, she proposed that privacy should be a collective right. And I believe that privacy is collective in the sense that depends on our social circle, but I'm partially disagree in that it should be a collective right, where in the United Nations is an individual right. But here we have the problem between doing everything that is not forbidden versus doing only what is allowed. And this is the case of GDPR, for example. And then we have things like digital nudging, which are very important. So we're being enticed to click to see certain part of the screen. And this is more related to my other talk on bias in search. And here, very important, having a consent or legal basis to collect the data, do minimal data collection, only the data you need for the purpose of the application, and of course, minimal time to store the data while the application makes sense. For example, COVID data. At some point, COVID data will, if in the individual level, shouldn't be stored. And here is Article 22 of GDPR, and here, very important, you need to contest the decision. But how we put the same in practice is that if you want to be transparent, you want to have interpretability, if you want to have people contesting your predictions, then you need to explain. And of course, you need to do this all the time, so you need continuous validation, testing, and maintenance. So GDPR in action, so was very important judicial landmark in south of France in last year, 1 year ago, and where they said that the school didn't have the competence, didn't have the consent of the people, and the action was not proportional, and basically using GDPR, this was terminated. And today we see other cases against Uber and other companies in Europe using GDPR. But one problem with GDPR is that one size fits all. So it doesn't matter the size of the company, doesn't matter the size of the data set, doesn't matter what human rights, it's everything together, which also causes other problems. And this is what Lorena calls technological solutionism versus normative solutionism. At the end, it's the same. And then regulation, we have the antitrust cases against Google and Facebook that started last year in the US. There are many other antitrust issues. There are also ethical issues on e-commerce, like should we sell in our own marketplace where we know all the data? Well, supermarkets does this, but here the asymmetry is even more strong because you have all the data. And I believe that fair markets could be better revenue-wise, and I'm finishing a paper that I hope I publish soon on how doing more exploration will be better for companies when they use reinforcement learning for recommendation. And of course, ethical boards should be compulsory everywhere and at least 50% external, because otherwise you can fool the system. And I hope with Biden we'll have future regulation. There were some laws that were proposed that were not approved in the last year, but maybe soon these things will pass. We need to do more ourselves, things like auditing algorithms, registering algorithms. These are important, and these things are appearing in Europe. So I will not be able to read this because I think I'm over time, and I want to leave some time for questions. So these are some
10 minutes, Ricardo. Take your time.
Okay, thank you. So bad human practices. Basically, a lot of things we do when we develop code. And this is based on a very interesting article written by Gina Matthews that appeared last year, so I recommend to read it. So about all our bad practices. And then we have many professional biases. For example, we have a bias to think about big data when most companies will never have big data. They only will have small data. I have an opinion article about that in KD Nuggets. Then we have design implementation. Do systems reflect the designers? Do systems reflect the coders? And in my 2018 paper, I used this very interesting experiment on data science to say that probably the answer is yes. And last December, a paper from Norway basically gives the first insight that yes, the bias of the coders can be transferred to the code. So this is an archive. I would suggest to look for it if you're interested in this. And really, this is like indirect bias, and it's much harder than all the other biases that I have mentioned. But I'm sure that, for example, if women develop a system, the system will be, let's say, maybe more empathic than a system developed by men. And then evaluation, there's a very nice talk by Julio Gonzalo in ECIR on how we basically fool ourselves when doing evaluation. We have to choose a lot of things right. And of course, we want the paper to improve science, but then the evaluation is harder. So what we can do, and this will be, I'm finishing. So for data, you can be aware of the problem and look at data and try to not use attributes associated directly, indirectly with harmful bias, but also you have to check that that bias is not encoded in other attributes that you think they are not associated, but we know that, for example, postal code can tell a lot about, for example, ethnic descent in a city. Interaction, make sure that the user is aware of all the biases all the time, give more control to the user, and when you are designing and implementing, let people contest all your hypotheses, invite ethicists, invite super users, invite normal users to contest your solution. And evaluation, basically do not fool yourself again, and also try to be transparent with your system so other systems can check that what your claim is true. So some other recommendations: design for people first, have an ethics board, and enforce a code of ethics. Of course, explainability will be important if you're in the European Union. I prefer to have humans in control, no humans in the loop. We are the designers, we are the masters, we are playing God, so please remind this, we're not only in the loop. And very important, there's no ethics if you don't check the ethics of your providers and clients. Ethics is like privacy. It doesn't matter how ethical you are if the rest of the world doesn't have the same ethics or is less ethical than you. You need to check the whole system. So ethics is complicated, so do not underestimate it. And I finish with two interesting articles. So also recently, Hazel Henderson asked, can AI algorithms ever be ethical? I will not give you the punchline, but for example, in this paper that is in the first issue of the journal of the new journal of ethics in AI, the first issue is all free, that you cannot have AI ethics without ethics. Yeah, obvious, right? But some people forget that. So first, if you want to have AI ethics, your company needs to be ethical. So otherwise, clearly, you will not be able to handle ethics. And sadly, in big companies, ethics is not the strongest skill. So just I have this my favorite data science sayings, but I think people can read this later. So I will take, we'll skip the joke. I will take questions.
Thank you very much.
And I can take biased questions, but then I will give biased answers.
So, guys, you know, you can write the questions either in the question answer box or in the chat. You should see both of them, Ricardo. So Jean-Baptiste.
Yeah, so I will consider the first question then. So let me read it. When you analyze a model in the spectrum of ethics, do you look mainly at the output of the model or at the training data? Is there some way to locate unethical data within a data set, maybe labeling a portion of your data set and training a classifier to evaluate the ethicity of a data point? Yes, you can do that. But the problem is that sometimes you don't know what is the bias. So this is one of the main problems. So if we're looking for gender bias, that will be easy, right? But let's say you are looking at the problem that the judge had with delivery in Bologna. That bias was much more subtle, was indirect discrimination with people that didn't want or couldn't deliver food at dinner time. That will be very hard to guess from the beginning. So you need to look at the output too. So the real answer is that we need to do more research on how to measure bias, both in inputs and in outputs. And this is something that very interestingly, if you look at statistics books, you don't see many papers on how to measure bias. So which was a surprise for me. So in some sense, maybe we don't want to measure bias, right?
Okay. Then there was a question also up in the chat by Vidas. Could you provide some practical guidelines or general algorithms on how to measure, evaluate the amount, level of ethical bias in AI systems?
Sorry,
I can pass it again.
Okay, no, I have, okay, here. So some practical guidelines. Again, the problem yeah, so at least I will do some very simple experiments. So first look at the data yourself. So take samples and look at the data. For example, one thing I do, but I haven't seen this formal, is that you can take, for example, 10, 20 different samples, and for example, check if you have the same distribution in every sample. And maybe you bias the sample. So let's say I do some kind of unbiased, a kind of biased sampling, and I again check if the distributions are the same or not. For example, do they have the same bias that I put or not? So all these things will show you if you have some bias that is relevant in the sample. Of course, there are many within quote biases that are information, so they are not real biases. So there are no systematic deviations. So you need to have a systematic deviation to have a bias. So yes, we need to build more tools. There are some tools. So there are some tools available from IBM, from University of Chicago, that allows you to do these measurements. But I think we need to do more research on this.
Thank you, Ricardo. I would have a question as well. I mean, what about teaching our students these issues about bias and ethics in AI? I mean, it's not that trivial to fit these kind of competencies in a typical technical curriculum, also because of time reasons. So you have to teach a lot of stuff, and also because they are very enthusiastic on whatever new technology, but reflecting is much harder. So do you have any advice about this?
So I would say that today a course on ethics and technology should be compulsory for a computer scientist, because basically ML-based algorithms are so frequent now, so used, that you need to understand what are the good things and bad things about these algorithms. So for me, I will have a ethics in technology compulsory course that should be taking maybe not the last year, because you need to learn these things earlier, but for example, in second or third year of your career. It's like fundamental society and knowledge that you need to do. So I think there are more questions.
Yes.
Diort, so hi Diort. You mentioned some applications that are wrong, whatever. Are there such applications in information retrieval? What things should we not do as a community? Very good question. I think you already know the answer, because you have worked about search for children. But for example, if I'm searching something that I know that will harm people, should I give you the answer? Let's say I want to build a bomb. Should I give you the answer? Maybe that information exists, I'm sure it exists. Should I give the answer? Should I say, no, this is not ethical, I will not give you the answer? People do this. So we have to think more on not trying to do things automatically, also have a human touch to things. So yeah, so I think in many cases, searching for things that you shouldn't do, or for example, something that may involve hate and similar, we should have like an ethical search. Ahmed asked, human in the loop and human in control. So it's just that when we say human in the loop, it looks like the one in control is the model, is the algorithm. However, in practice, we are the builders of the model, so we should be all the time in control. It's just to have this semantic distinction that we are the masters, not the algorithms. It's not like we do a model and then we need the person to check if the model is doing right. No. There are a lot of people involved in a model. People that level the training data, people that did the design, people that did the implementation, people that did the evaluation, people that did the validation, and so on. All of them are responsible of the final result of that model. So Arjen, hi Arjen, how are you? So he asked, might be easier to construct bias reference point with the goal to stay away from those than to construct unbiased reference point with the goal to get close to those. Yeah, so I agree that this could be easier, but also that we can go in the right direction. So we don't need to construct any of those reference points. In many cases, we know which direction we should go. So for example, we know which direction we should go in gender bias or race bias. So we go in that direction, and then where we're feeling getting closer to the right solution, we can worry about the reference point. But in many of these cases, we are far away. So for example, I will take the example here, but if we want more women in STEM, if we have 15%, we know that we're far away. So maybe we can worry when we get to 40% about what is the right reference point. But having in a school in India, where 60% of the computer science students were women. So there are many different standards. Norbert, how are you? Question from Norbert. Is transparency of the model essential for ethics? And are neural networks thus to be avoided? That's a very good question. So first, no, I'm not saying that the neural networks should be avoided. I'm saying that if we can harm people, we should think twice about the technique that you need to use. Maybe in some cases, we can even use techniques to measure basically to understand what the system is doing, things like LIME and other techniques that basically are independent of the technique of machine learning we use to see if we have a problem or not. And of course, in some cases, we don't want maybe full transparency because then people may game the system. But in that case, we may want to have accountability. The problem that in the UK, people ask for accountability because they trust the system. In Italy, people ask for transparency because they don't trust the system that much. And this is the problem with different cultures. So what we ask depends a lot on the culture. And then the answer is not the same, let's say in the US and in the EU. And of course, it's not the same in China. And this is the problem. So let's not try to think that there's a common ground truth. But this is a partial answer. I think we don't know the full answer for your question. Or at least I don't know it. So Felice asked a question. I wonder whether the trade-off between an accuracy and fair and biased, robust, privacy-preserving model has to become a standard benchmark when submitting a new work considering the social impact of all these aspects. For instance, new and social recommenders are pretty essential and impactful scenarios. So we have to, I think, go one step at a time. I think that would be a great future. I'm not sure we can do it right now. But for example, there was a controversy in the last NeurIPS because people don't like to do the ethical statement of the paper. Let's say, can your application harm people? I believe that should be done. So first thing, you do an ethical statement. We thought about the issue. Yeah, maybe the ethical statement is we haven't thought about it, but that still is an ethical statement in the sense that you're being transparent about it. But for example, the next step will be try to do error analysis. How many papers on machine learning do an error of the prediction? And where did they do the error? I'm sure that the error doesn't exist for places where the problem is easy on the problem space. But they do bigger errors in places where the problem space is hard. So instances that are hard. And in search, we have many of these cases. And then the errors there may be more impactful. So maybe that's, and I'm doing research on that front. So basically on the impact of errors.
Then, Ricardo, there was a question by Fabrizio up in the talk. I have pasted it again in the chat, this one. You mentioned awareness. Can you see it?
Yes, it's one of the 7 bullets for algorithm transparency. So isn't awareness sometimes more complicated, made complicated by the lack of agreement of what constitutes biases? What is a bias setting for person X might be an unbiased setting for person Y? Isn't bias in the eye of the beholder? Yes, and that's why one of my challenges in the talk is cultural differences. So in some places, some things are correct, in other places things are not correct. In some places, some things are illegal, in other places they're not legislated, and in other places something legal is illegal. So we have these issues, and this is true. But I believe that at least we agree on human rights. I think we have an agreement on human rights, and at least in human rights, we should try to basically be aware. So for example, a system that harms the rights of people, basic rights, like freedom of expression or privacy, we should look at that. Of course, if we go to other cases, we need to do like a tailor the solution to every country almost.
Thanks. So there are a couple of raised hands. So there is Jeremy. I think you could directly talk, Jeremy, and ask your question if you wish.
Oh, I'm sorry, that was by accident. I'll lower my hand again.
Oh, hi, Jeremy. Nice to see you here.
And you too.
And so second raised hand is by Yannick.
Yannick, go ahead. How are you? You just put your muted.
If you wish. Okay. Maybe it was a.
So I see many hands on the list. So hello to all of them.
So guys, do you have any other questions for Ricardo and for his very inspiring talks? So we are basically almost on schedule, at least for an Italian guy. So Ricardo, thank you again very, very much for your talk.
Thank you, Nicola, and have a good luck with the rest of the conference. To Fabrizio and Rafael.
And now we can move to the Italian cooking session, I could imagine.
Great. Can we eat also?
Yeah. Bye-bye to everybody.
Bye.